Okay, before we actually get started using two-step equations, we have been solving for a while quadratic equations, right? So we're going to start a list of ways we know how to solve quadratic equations. What's one way we can solve a quadratic equation that we've learned so far? Okay, well, I'm going to tell you right now, you only know two. I'll give you a hint. What's one way we can solve a quadratic equation? Taking square roots. Great. So that's one way we can solve a quadratic equation. I put it in number 2 because that's the second way we learned. How else can we solve a quadratic equation? Which is what? Which is what? Factoring. Remember, at the end of learning all 4 methods, I'm going to give you a problem and I'm going to say solve it. You're going to use one of the methods to solve, so you can't forget all of them. Okay, so right now we know how to factor, and we're learning how to take square roots. Everyone with me? Okay, a recap from Friday. If I want to solve x squared equals 16 by taking square roots, what would I need to do? So I'm going to solve x squared equals 16, and I'm taking square roots. Sophia? Okay, so I'm going to take the square root of each side, because whatever you do to one side, you have to do to the other. And what's the square root of x squared? X. What's the square root of 16? So my answer is x equals 4? Plus or minus? Don't forget, you always will have those 2 answers when you are solving by taking square roots. Super important. Okay. Today we're going to focus specifically on, so this was a one step, right? I took the square root of both sides. Everyone agree I did one thing, really? Yes? Okay. Today we're going to specifically focus on 2-step. So x squared plus 1 equals 45. Now it's very similar to our warm-up, except we have an x squared. We know we're going to take square roots. But when you think back to IM1 and solving equations, you deal with the addition subtraction first, and then multiplication division if you have it, right? So what do I need to do to get x squared by itself? That's where we have to start. Subtract 1. Great. So I'm going to subtract 1 from both sides. So x squared equals 44. Does that look exactly like what our lesson on Friday looked like? Yeah? Okay, so to get rid of the squared, I'm going to take the square root of both sides. Square root of x squared is x. Square root of 44. How can I find the square root of 44? Factor tree. Give me 2 numbers that multiply to 44.
11.
Okay, so 4 and 11. 4 breaks down to 2 and 2. Does 11 break down? Okay, so I have a pair of 2's and a leftover 11. What comes out?
4.
The 2, and then the 11 stays in. That's what's left over. And what can I not forget? Plus or minus. Okay, so we're literally just adding a single step to today. Can we handle that? Yeah? Do you want to try one, or you want to do another one together?
Never one together.
Okay, one more together. So n squared minus 4 equals 96. Where do I start? Add 4 to both sides. Great. So n squared equals 100. And I want to get n by itself. Is 100 a perfect square? So n equals what? Ooh, did y'all just say 10? Plus or minus 10. Are we okay with that? Okay, so you try this one. Let's do... Okay, so where did you guys start? Adding 3 to both sides. Now, some of you are going to do some of these steps in your head, and I'm okay with that, but you shouldn't go from the question to an answer right away. You got to give me something in between, okay? So r squared equals negative 45. Then you take the square root of both sides. 45 breaks down to what? 9 and 5, okay. And then 9 breaks down to 3 and 3, so I have a pair of 3s and a leftover 5. And what else did you notice? There's a negative on the inside. What does that mean? Means it's going to come out and become an I. So R equals plus or minus. I have the 3, I have the I, and the leftover 5 stays inside. Okay, so some of these are going to have imaginary numbers. Some won't. You just have to be cautious and watch for that. So far, so good? Yeah? Okay, what about, let's do this one together. Okay, and again, we're still trying to get the variable by itself, but we don't have a plus or minus here. We have negative 4k squared. So how do I get k squared alone? Divide by negative 4, because I want k squared by itself. Those negative 4s are going to cancel, leaving me with k squared equals what? 61? Okay. Does it look exactly like Friday now? So the goal, as always, when you're solving, is to get your variable alone. I'm going to take the square root of both sides. Does 61 break down at all? Okay, so if it doesn't break down, k equals plus or minus the square root of 61. So in this case, 61 doesn't break down, so I'm going to leave my answer as is. So because it's a negative divided by a negative, I don't have an I in this one, right? Because it's positive. You okay with that? Okay, so you tried this. Oh, nope, let's do this one together. Wow. Okay, same rules apply. Our goal is to get n squared by itself. So what has to move? The 16. And how do I get rid of the 16? Divide. Okay, so when I divide by 16, they cancel on the left, and I'm left with n squared equals. Does anything simplify on the right? No? So you're going to leave it 1 over 16, no decimals. Okay? Don't freak out yet. Our goal is to get n by itself. So how do I get n by itself? Square root both sides. What's the square root of n squared? N. Okay, here's how you're going to deal with fractions. You're going to take the square root of the numerator and the denominator separately. What's the square root of 1? 1. What's the square root of 16? 4. Am I missing anything? The plus or minus. Okay, so if you have a fraction that you take the square root of, deal with it separately. In some cases, you might be able to take the square root of a number, but like of the numerator, but not the denominator. And you may just have to simplify. And that's okay, but you're going to do them separately. Maybe let's make a note. When taking a square root of a fraction, take the square root of the numerator and then the denominator. Okay, you think I can give you a couple to try?
Or not.
Let's do
You ready? They can't see.
Okay, I want you to try these 3. Okay, number 6. You should have started by dividing by -8. And you get p squared equals a positive 84. Square root both sides. What did 84 break down to? No, like how? Give me 2 numbers that multiply to 24 or 84. 4 and 21. Okay. 4 breaks down to 2 and 2. 21 breaks down to 3 and 7. I have a pair of 2s, a leftover 3, and a leftover 7. So you should have p equals plus or minus. You took out your pair of 2s. 3 times 7 is left over. And that gives you 21. Okay, that one was okay. Number 7, we got through part of it. So start by dividing by -100. And you get a squared equals, what's 24? That's not a 24. What's 25 divided by 100 if I was going to simplify that? 1/4. But it's a -1/4 because I have a -100. Okay. Take the square root of both sides. And remember, when we have a fraction, we're going to do them separately. So a equals plus or minus, what's the square root of 1? 1. What's the square root of 4? 2. Did you notice anything else? There's a negative. which makes an I. Yeah, you should put it, it should always come after that number. If there was a radical, it just has to be in, so it doesn't have to be in front of the radical. The problem becomes, so like, okay, so say this was our answer, right? I tell you to write it in front. The concern is if you write it behind, what does that look like to you? Where does the I look like it is here? Inside the radical, which it can't be. So if you're going to write it afterwards, it has to look like it's outside of the radical, which is why it's easier to just write it in front. Okay? Okay, so we're good with that one. Last problem. Where do we start? Add 3 to both sides. So if I add 3, I get k squared equals 16. Take the square root. K equals plus or minus 4. Most of us got through all of those. There was a little trip up on that one, but it had quite a few steps. How do we feel? So on a scale of 1 to 5, are we still hopefully in the 4 and 5 range? Yeah? Awesome.